us learn spherical polar coordinate system. Spherical polar coordinate system. In spherical polar coordinate system, the position of point P is fixed by using three coordinates and which are r, theta and phi, where r is known as radial coordinate, theta is known as polar coordinate, phi is called as azimuthal coordinate. These three coordinates in spherical polar coordinates now let us see first radial, that is the coordinate r. There are three coordinates. Let us see first coordinate, the coordinate r. Or r coordinate. Okay. What is r coordinate? It is a distance of point P from the origin. If you draw Cartesian coordinate system, first draw Cartesian. It is easy way to show any coordinate system in terms of Cartesian coordinate system, and therefore we use Cartesian coordinate system. Now suppose this is point P from the origin. O is the origin, P is a point, then OP bar is the position vector of point P. That is, r coordinate is the distance of point P from the origin. The distance of point P from the origin. This is r coordinate. Okay. It is vectorically it is written as r bar, and in magnitude we can write r. It has a dimension of length. Next coordinate, the coordinate theta. What is theta coordinate? The angle theta is the angle between OP and Z axis. Let us choose here Z point, small z. The angle ZOP is known as polar angle. Angle ZOP is theta. It is the second coordinate in a spherical polar coordinate system. It is also known as polar angle. Let us see third, the coordinate phi. The angle phi is the angle between x-axis and OQ. What is OQ? It is projection of OP on xy plane. Projection of OP on xy plane, like this. This is xy plane. The projection of OP on xy plane is OQ. And this is phi. That is angle between, suppose this is M and this is N here. Then angle MOQ is phi. What is phi coordinate? It is angle between projection of OP and x-axis. Is coordinate phi. It is also known as azimuth coordinate. Now there are coordinate surfaces in spherical polar coordinate system. Let us see coordinate surfaces. There are three coordinate surfaces. First coordinate surface is R surface. In spherical polar coordinate system, the surface for which R coordinate is constant is known as R surface. Now see, this is Cartesian coordinate system. We have drawn spherical surface. Here is R coordinate, and R coordinate is constant. If you draw for any point on a surface, R is constant, known as radius of sphere, and therefore spherical surface is known as R surface, for which R is constant. This is first surface, R surface, which is spherical surface. You have to draw only diagram like this, and this is a spherical surface or R surface. Second, theta surface. Now how we can show the theta surface? Suppose this is coordinate system, and this is when angle theta. Here also angle theta is between z-axis and position of point P. If the position of point P is here, we have again this is theta. Okay, and you can draw like a surface like this. For this conical surface, R is constant. It vertex at origin. Okay, conical surface having vertex at origin. This is conical surface for which theta is constant. Means on this conical surface, for each point theta coordinate is constant, therefore is known as theta surface. It is conical surface. Now third, phi surface. Now how we can draw phi surface? Let us see. Let us draw this Cartesian coordinate system. Now we know angle between this is phi. You can draw this phi surface. This is phi surface. Okay. For all points on this plane, phi angle is constant. Therefore, we can write phi constant, phi equal to constant, and the surface is plane, half plane surface which has one edge along z-axis. It has one edge along z-axis and other is extended, okay, towards required point. Therefore, this is known as half plane surface. This is phi surface, half planar surface. We have seen these three coordinate surfaces. Let us see coordinate curves. Now let us turn towards coordinate curve. Coordinate curves. There are three coordinate curves in spherical polar coordinate system. Let us see first R curve. We know a curve in a curvilinear coordinate system for which one variable is variable and another two variables are constant. Now how we can draw the diagram of R curve? This is Cartesian coordinate system. This is OP. This is known as R curve. If we change the position of point P, we see that R is changing, but other two coordinates are fixed, and therefore it is known as R curve. Next, theta curve. How you can draw theta curve? Consider Cartesian coordinate system. Now we know this angle is theta, and when this angle theta will be vary if we change the position of point P like this, you will get a circle. That is, theta curve is circle of radius r, we can say, and this circle is along a phi plane and along r plane. This curve will be on r surface. What is r surface? R surface is spherical surface. It is along r surface, and also it is along phi surface. We know phi surface. Therefore, this is theta curve on which only theta coordinate is varying. Angle between z axis and theta. If you change here, angle will be changed. This is known as theta curve. And third one is phi curve. How you can draw phi curve? Draw curvilinear coordinate system. Cartesian coordinate system. We know angle between this x-axis and this OQ is phi, and if you change the position of point, suppose Q is here, P is here, and if you change the position of point Q by changing phi, you will get circle. Nature of the curve phi curve is circle, but this phi curve is along xy plane. Okay, for which r is constant and also theta is constant, and phi coordinate is variable and other two are constant. This is known as phi curve. Next, move towards